Welcome back to Concepts in Arithmetic. In this video, I wanted to talk about some common mistakes that you might see students making with fractions. And one of the most common would be just adding straight across without finding a common denominator. Okay, so what we want to do is we want to show them why this doesn't work. We don't just want to say, well, you can't do that because you need a common denominator. That's not an explanation, that's insisting that we need to do it using this rule over here, but of course that's not explaining why this isn't correct. Okay, so this is a great time to bring up counterexamples and contradictions. Okay, so let's start by supposing fractions did work like that. Okay, so this student is claiming we can just add fractions straight across. Okay, suppose that was true. If that were true, then 1/2 plus 1/2 would be 2/4, or 1/2. Okay, now this is trouble here because I know from just everyday experience that if I have half of something and then I have another half, I would have a whole of whatever I'm talking about. If I have half a cookie and another half a cookie, that's equal to a whole cookie. But this is saying that I still only have half a cookie. So that's a contradiction. That's a situation that we know can't be true. So this premise that we can add fractions this way leads to absurdities. Okay, and this is a good technique to use to demonstrate why this isn't the way it works. Okay, it would be wonderful, it would be easier to do fractions this way, but the world just doesn't go like that. Another example. If I could add fractions like that, if this were true, and let me put like a question mark over here, because we know this isn't really true. 1/2 plus 1/2 is supposed to be 1, but if I'm doing that, then I would do that. Okay, suppose I were to add this by saying this is 2/5. Well, if this were really true, I took 1/2, I added something to it, I got 2/5, but if I cut something into 5 parts and I only have 2 of them, I have less than half the parts. So I took 1/2, I added something, and I got less than what I started with before I did the addition. Okay, so yet another illustration that adding fractions straight across just doesn't work in the way that we know arithmetic is supposed to work.